Welcome children. So we are here back on the questions from examprep.world under topic of probability, and here we are going to do type 4 questions which include probability of compound events. Dependent events. So dependent events is when one event is dependent on other. So we will see how these dependent events are. We'll take up the first question, you will understand in this. Look at the question. I suggest you also open examprep.world, learn and practice, choose the topic of probability in the drop down and select question type 4. So you will get this question, which is the first question there. So here we have two jars in which we have gold coin and silver coins, and in pot B also we have gold and silver coins. So they are telling when some coin is selected at random from pot A. From pot A, you are selecting some coin, which can be either gold or silver, and you put it here. So there will be some probability of gold and silver, correct? Then you put back one more coin, select from here and put it back. Second event. Now this event is dependent, suppose gold was here, then probability of gold going back is more. And if it was silver coming from here, then probability of silver will be more. So when you are selecting from here, it is dependent on what came from pot A. Now you are seeing the dependent events. And final, the question is, after doing that exercise, moving one coin from here and another random coin to here, you are actually selecting final third coin from pot A. And they are asking, what is the probability that coin, third coin is gold? You understand the question? Once again, I am going to repeat. We select a coin random from A, put it in B. There can be two options, either it can be gold or silver. If gold goes there, then probability of gold coming back is also more. If silver goes there, the probability of silver coming back is more. And when you third time you select a coin from here, it depends upon the two events, first selection and second selection, right? So let's do mathematically how this is done. Okay, so for this type of question, the best form is draw a tree diagram. Okay, so let's begin with the tree diagram. In pot A you have, let us first count how many gold and silver. I see there are gold are 1, 2, 3, 4, 5, 7 coins are there, and silver there are 4 coins. Together they are 11 coins total. Pot B also we will do. Gold is, we find that there is only 2 coins and silver are 4 coins. Together there are 6 coins in here. Okay. Once we know this primary data, we can go ahead and draw our tree diagram. Let's do that. So first you are selecting from pot A, event 1. So either you are going to get a gold or silver, correct? Either you will get a gold or silver. Then second, you will again get a gold or silver, gold or silver. Third time, once again you are going to do, where you will get gold, silver, gold, silver, gold, silver, gold and silver. Once you know that these are the things, now we have to put the probabilities of each event. Okay. Now, what is the probability of getting a gold? 7 out of 11. So I will use a different color to write the numbers, and I will shift this so that we can do it more in a better fashion. So we have the numbers, and let me zoom a little bit, writing will be easy. Now that is okay. But we want to see those numbers too. So what I will do is I will drag this one over here. So that we can see. Now, if you want to read the question, read from the website. Parallelly open along while you are watching video. Parallelly open the website too. As I told you, go to learn and practice. From the drop down menu, select probability and go to type 4 question. This is the first question. Okay. Now we know the probability of selecting a gold is 7 on 11. This is 7 on 11. And then probability of selecting a silver is 4 on 11. 4 on 11. So we have written the first probability, first event. Now when we are doing second event, suppose the coin was going gold here. So it will become +1, and here also it will become +1 if it was gold. So probability of selecting gold is 3 on 7, and probability of silver is 4 on 7. Why? Because total is increasing, 4 on 7. And in first time, if it is silver, then what will happen? 7 will be as it is, gold will be like this. From here you will get, from here you will have +1 +1, which is 7. Okay. So now probability, once you have silver, then second time you are getting gold is how much? Just 2. 2 on 7, because there were only 2 gold coins that time, but silver increased by 1. So here you will have 5 on 7. Okay. The probability of second event is very clear now. Okay. Now third event. Now imagine a gold went into second gold. Now there are obviously 3 golds there. Now we are picking 1 gold coin and bringing it back into the first spot. In first spot, how many gold coins are there? Because 1 gold was already gone there. So it will be 6 gold coins here. So probability here will be, and if 6 and +1 coming, so it will become 7 on 11, because 1 less, so it is 7 on 11. Understood? The gold which went to here and it's coming back, so the gold coins is back from 6, it becomes 7, and total becomes 11. Now if it is silver, in third option, if it is silver, how many were there? Gold, silver were only 4. 4. Now we are selecting from the first box. So 4 on 11. Clear? I hope I have done correct. 7 on 11 and 4 on 11. If silver comes back. Now selecting gold. Gold, silver, gold. If second is silver, that means the gold didn't go there. So gold are how many originally? First gold came. So number of gold is still 3. 3, and once it is back, so it will be once again 7 on 11. No, there will be only 6 golds at that time, right? 6 on 11, because 1 was silver. Now 6 on 11, and silver will be 1 more, because 1 silver came here. So it will be 5 on 11. Okay, clear? Now it was silver, gold and gold. First was silver, so gold were intact, 7. Then you had gold, and then you had gold. Then it will be 8 on 11. And silver, gold. So now it will be 3 on 11, because 1 silver had gone. So it becomes, see, 8 plus 3, 11. It should be 11. Now silver, gold. 4 on 11, 5 on 7. So first silver, that means gold is intact. Then again silver, gold is intact. So once again, once you get 1 more gold, it will be 8 on 11, and it will be 3 on 11. Now with the tree diagram which is completed, so we can calculate the probability of getting gold. In how many ways you are getting gold in the last step? So let me mark them. Look at this place thing. You are getting a gold here. So first you will calculate all these probabilities. Then you are getting 1 more gold in the third option. So you will calculate this probability. You will add them. Then you are getting 1 more gold. You will calculate this, and 1 more. There are 4 routes where you will get gold at the end. 1, 2, 3, 4. Looks like finger of a human, right? 4 fingers. Thumb should be here. So now our job is to total them. The first getting a gold is, I'll use black color to do that. Yeah. The first is 7 by 11 times 3 by 7 times 7 by 11. 7 by 11, 3 by 7, 7 by 11. We will get some number. Next, 7 by 11, 4 by 7, 7 by 11 times 4 by 7 times 6 by 11 plus 4 by 11, 2 by 7 and 8 by 11. And final thing, 4 by 11 times 5 by 7 times 8 by 11. So you get all these probabilities and add. That will be your answer. So you picked one from A, you sent it to B, then you are picking some B from A, and then third time you are picking from A. So probabilities of gold, in 4 ways you can get the final gold, 1, 2, 3 and 4. We have written all the probabilities. Now let's calculate this. We'll cut this 7, 7, 21 by 121. We'll cut again this 7, 7, 24 upon 121. We'll cut, we can't cut anything here, 64. 64 upon 121 times 7. 121, 847. And then we have 40, 20, 60, 160 upon 847. Now when you add all this stuff, you will get your answer. Let's simplify. 21 plus 24, 45, 45 upon 121 plus 64 and 160 becomes 224 upon 847. Now we can calculate this to get our final answer. Let me do it for you. 45 over 121 plus 224 upon 847, 7 on 11. So that's the probability you have for finally getting a gold coin. So I hope you have understood. In this question it was a little complex because there were 3 events, and the third event is dependent upon the first 2 events. The second is dependent on first, and the third is dependent upon the second, and which is in turn dependent on first. So it is little complex, but I suggest you pause at different points and try to solve them, so you will be able to do. Okay, I'm moving away from screen. Please copy. Okay, so we have done this, so let's go ahead and try to do the next question. So here, Matt is the best player in his lacrosse team, and he has injured his knee and has only 60% chance of playing the next game. So there's a guy who has injured his knee. We don't know whether he's going to play the next game or not, but there are chances, 60% chance that he will play. The team has 70% chance of winning the next game if Matt plays, right? So it's not sure if Matt is not a Superman, right? If he plays that, even then the team may fail. So there is only chance of 70%. If Matt plays, but only 45% chance of winning if he does not play. But if he's not playing, chances are only 45%. Okay. So make a tree diagram for given situation. The first thing is Matt plays or he does not play. And second, team wins or does not win. So there are only 2 things. So let's calculate. First, let us do Matt plays. This is about Matt. He plays, no play. So either Matt plays or Matt does not play. What is the chance that he plays? 60%. And what's the chance that he does not play? Is 40%, 100 minus 60. Okay. So now once we have this, then team wins. Wins, lose, wins, lose. Okay. So what is the chance of team winning? 70% if Matt plays. Then losing is 30%. And if he does not play, chances of winning is 45%. Losing is obviously 55%. Now we have written with percentages. What's the probability? We'll write the probability with a different color. I hope you have written this right. You have read the question. If there is some problem, you can read the question parallelly on the website examprep.world. Now let me write the probabilities with a different color. 60% is 0.6, 0.7, 0.3, 0.4, 0.45 and 0.55. So tree diagram is complete. Find the probability that team will next game. So where are the wins? I see win is here and win is here, right? So calculate the probability. To reach this win, we have to multiply 0.6 and 0.7. So probability of winning is 0.6 times 0.6 times 0.7 this root plus this root 0.4 times 0.45 plus 0.4 times 0.45. If you add them, you get your answer. (0.42 plus 0.18. So if you add them, 7, 0.7, 40, yeah, 0.6, 42.6, 0.6. Now 0.6% the chance is that team will win. Now we have all the situations here dependent on Matt playing and Matt not playing. If he's not playing, the chances are less. So this is dependent events. And now we have the probability of winning. How did we do? We went in this route. We calculated this part and then we calculated this part. And we added both the probabilities. Okay. So pause the video and write it. Let me zoom out for you so that you have clear idea of what we have done here. Yeah, I'll move away from the screen. Please note it. Done, guys. So let's go and see the next question. Now they are talking of a drawer which has 5 blue pens, 3 red pens, 2 green pens. There's a drawer, table drawer, and where the blue pens. So let us capture the data. Blue pens are how many? 5. Red 3 and green 2. So, okay, see, in a drawer there are 5 blue pens, 3 red and 3. Now we are opening the drawer and not seeing, collecting one pen from there. We are not seeing which pen we are taking. Just then we will get probability of any one of these, right? And then we are keeping this pen aside. Then we are selecting second pen. Now one pen is less in the drawer, right? So the probability will change because it is dependent on my first selection. I have taken one of the pens, I have kept it aside. Now there will be one less, then probability will be lesser. So we have to draw a tree diagram and calculate the probability for our required. Exactly one of the pens is green. Okay, so let's calculate. So we get, there are two events. So look at this. So for drawing the tree diagram, I need little space. That's why I have zoomed it out. So either you will get a blue or red or green, right? When you pick up, you will get either this. What is the probability? What are the total numbers? 10. It is 10. So getting a blue is 5 on 10. Getting a green is 3 on 10. Getting a red is 3 on 10, and getting green is 2 on 10. Now you have taken one pen and not replacing it. Suppose if it is red, or suppose if it is blue. Blue, red, green, blue, red, green, blue, red and green. Second pen can be anything, either blue, red or green. Now if you have already taken out a blue, one blue is less, right? So it will be 4 on 9. But if blue is gone, red numbers will be same. It will be 3 on 9 and green will also be 2 on 9, because only blue went off. Red and green are still there, the original numbers. And total is reduced by 1. Now if red is gone, blue will be there, 5 on 9. This red is gone, so it will be 2 on 9, 1 less. Okay. Now green is 2 on 9. See, second event when the red is gone. Now let us assume that green was taken out in the first attempt. So when green is less, so blue are intact, 5 are there, 5 on 9. Red will also be 3 on 9, but getting green is just on 9, because one of the green already came out, only one green was left. So 1 out of 9. Now look at the question. Exactly one of the pen is green. That means blue and green, this is the first thing. One of them is green, so we will mark that. Here blue, 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 red, blue, green. So here one of them is green, and then one more option, red and green, and green and blue, and green and red. So 1, 2, 3, 4. These four probabilities will add up, we will get that exactly one of them is green. So let's do that. Pause the video right at this point. Now let us do the calculation of the probability for this answer, answer 2. So it is 5 upon 10 into, what did I write here? It should be 2 upon 9. 2 upon 9 plus 3 upon 10 times 2 upon 9 plus 2 upon 10, 5 upon 9 plus 2 on 10 and 3 on 9. 2 on 10 and 3 on 9. Now if you calculate, you get a probability. Let's see, the denominator throughout is 90. So I'll write here, see, 90, 90, 90, the common denominator. So it is 10 plus 6 plus 10 plus 6. 16, 16, 32 on 90. Simplify this, 2 16 times and 2 45 times. The chances are 16 over 45 that exactly one of the pen is green. Right? You have understood this one? We have completed a tree diagram. We calculated the required probability. Okay. Pause the video at this place. I am moving away from the screen. Note it in your notebooks. So done, children. How are you finding this? Dependent events is easy, right? It is little complex, but if you understand it with slope phase, go slow. Try to understand step by step. See, one event is always dependent on the other if you are not replacing goods when you are picking up from the pots or a drawer. So that's why the probability will depend upon the first event. Okay. So let's go ahead and see what next we have. This is a pictorial. All of you kids like this kind of questions, I know, when there is a picture, but read the picture, read the question. Now a grog, no, it is a frog. There is a typo here. So this is a frog. Okay. Is in middle of 3 by 3 arrangement of square as shown in diagram alongside. Each time frog jumps, it lands with an equal probability on one of the adjacent squares. So wherever he jumps, the probability is equal. When he jumps here, here, the probability is equal. Now if he is jumping 3 probabilities, that means the probability of jumping here or here or here or here, everything is equal. That is what they mean. Now he makes 3 jumps. After 3 jumps, the frog lands in middle square. So after 3 jumps, so that means, look at this question. So frog can jump here, here and here, right, in the middle, or he can go like this, like this, like this, or like this, like this, like this, or like this, like this, like this. How many here? 1, 2, 3, 4. 4 ways, and 4 will be on the right side also. He can go like this, he can come like this, he can go like this, or he can come back like this. So how many possibilities are there? 8. So there are 8 possibilities, and total possibilities we will see. 8. 8 possibilities that frog can come into the middle square. So 8 upon the total number of possibilities we will see. But as of now we counted how many ways he can land in middle square by jumping 3 times. There are 8 ways. 1, 2, 3, 4, 5, 6, 7 and 8. Is there any other way where he can come back in the middle? But he has 1, 2, 3, 1, 2, 3, everything included, right? So let us also see the corner square. Now I am going to erase this stuff. If you want to note this, note it. Corner square. How can you go to the corner square? We will use another color for marking the corner square. I will use green. So he can jump like this, 3 jumps, or he can jump like this, 1, 2, no, sorry, 3 jumps. So 1, he can go like this, 1, okay, or he can go like this, because he has to jump 3, 1, 2, 3, 2 here. Similarly for this also 2 ways he can reach here, 2 ways he can reach here, 2 ways he can reach here, 2 ways he can reach here. Figure out. So now reaching a corner square is also in 8 possible ways. So middle thing we have done, corners we have done. What is left? The pink squares. Pink squares, in 3 jumps, how can you reach the pink square? Look, pink one. He can go here, 1, 2, 3. He can reach pink. Similarly, he can go 1, 2, 3, 1, 2, 3. 2 ways here. For this he can reach. Similarly, he can go like this, like this, like this, or he can go like this, and like this. From here also he can go 1, 2, 3. 1, 2, 3. So each pink square he can reach in 2 ways. 2, 2, 2, 2. Right? So that is also 8. So all squares are done. 8 ways he can do, 8 ways he can do, 8 ways he can do. Together it is 8 3, 24. 24 are the total movement which he can do. So what is the probability of middle square? 8 is to 24 is 1 by 3, and this is also 1 by 3, and this is also 1 by 3. It was easy, right? Initially, so only thing, you have to make your physical dog jump, no? With a pen, mark how many ways it can be done. I found that for reaching any square, whether it is corner, middle, or the edge one, the pink one which is in the middle, you can reach every square in 2 different ways. And then when it is 2 into, we have 9, 2 ways, 2 ways, 2 ways, 2 ways, 2 ways, 2 ways. 8, 8 and 8. So 3 different kinds of squares are there. So 8 times 3 is 24, and then hence we have the probability. Okay. I'll move away, note it. Guys, now let us see the next what we have. In a netball team, the goal shooter takes 65% of the team shots. This is one guy who always shoots the goal, and 65% times he takes the chances, and 70% he scores. Whenever he takes chance, 70% he scores. If he's not taking, 60% time. Okay. The goal attacks, there are 2 people. One is the goal shooter and the goal attack. When goal attack takes, other than the goal shooter, then 60% chances that they will score a goal. So the first event is whether who is taking the shot, goal shooter or goal attack. So let's draw the tree diagram for here. So dependent events, the best is the tree diagram. There are 2 possibilities. The first one, goal shooter, and the probability is this 65%. He takes the shot. Then left is 35%. Who is shooting? Goal attack guys. Goal attack guys. So shooter, attacker. Now if goal shooter is shooting, then chances is 70% is score. They will goal. No goal. So 70%, this is 30%, and when goal attack is doing, they do 60% success and 40% fail. So I'll write here fail. Success, fail. Now this is the tree diagram. Copy this. I hope, read the question and see if this is right. Now convert all these things into probabilities. Find the probability that they will score. So here they are scoring, here and here. So we have to multiply and add the probabilities the way which we are doing. So let me write the probability in a different color. 0.65, 0.35, 0.7, 0.3, 0.6 and 0.4. So when they are succeeding, it is 0.65 times 0.7, 0.65 times 0.7, I'll use a different color, 0.65 times 0.7 plus 0.35 into 0.6. 0.35 times 0.6. Now calculate this and that should be your answer. .665. That means 66.5% chance is that the team will score a goal. So pause the video and write. So now I hope with these kind of questions you would have learned dependent events. Okay. So with this, I think we have one more here before ending this type of questions. From a deck of 52 cards, you know playing cards, 52 cards are drawn one after another without replacing. Means we take one out of those 52 and do not replace it in the pack. So next time we will only have 51 cards. What is the probability that both cards are spades? So first we are drawing first event, probability of drawing a spade. How many spades are there? Probability of a spade. 13 cards are there each type. 13 times 4 is 52. So it will be 13 on 52. Assume that the card which we took out was spade. So one spade will be less there, right? So now second time when we are drawing spade will be 1 less than 13, only 12 will be spade, and total number of cards will be 51. Now it is very simple. Without the tree diagram we could complete it because there are two simple events, spade and spade. First time it was 13 on 52, second time it is 12 on 51. Now if both one after another it has to be spade, then the probability both spades will be equal to 13 on 52 times 12 on 51. Okay, now calculate this. One on 17. So we get answer is 1 on 17. Chances are there that we get both times spade. The chances are less. So many cards are there. So now I hope you have understood dependent events. With this we come to the end of this video where we learn dependent event. In next video we will understand conditional probability. One event based on some condition. Okay, till then practice this kind of questions from our website. Mostly I have done most of the questions, but there are a few questions which are similar to them. I want you to practice it. Okay, thank you. See you in the next video.